Well, hello again everyone. Today we'll be doing a little bit of a bonus tutorial just about a very specific algorithm which will be Demeo-like camera controls, which work absolutely great for top-down games. You wouldn't want to implement these for a typical first-person camera, but for top-down stuff they work great. So if you haven't seen it in one of my previous videos, it basically works like this. I've got my hand here, I grab using this controller, and then I move my hand. Obviously something is wrong. Ah yeah, the game is paused, that's probably it. Alright, let's unpause it. Let's try it again. And there we go. So it pulls you into the direction you're pulling. It's kind of like you're grabbing a rope and pulling yourself along the rope. Except instead of a rope, it's the world. And of course you can do it in all directions. You can put the world beneath you, do it like that, like that. Well, this is already very handy. Of course, there are some other tools you would want in this camera manipulation system, like scaling, which is very cool in my opinion. And suddenly the scale feels a lot different. You can scale out by grabbing both hands and just moving them further apart. And we can also rotate by grabbing both hands and just steering it a bit like a wheel. You can see that the grab move direction gets updated as well with our rotation, which is very important because otherwise people will feel very confused. Another important thing is that when I zoom all the way in to my player character, which is the focus point of this zoom, you can see that when I grab move, I move a lot smaller distance. Seriously smaller distance. Now when I scale back out again, I move a lot further, which is very important because let's say you want to go from the player character to the entrance of the fort there. If this was on the normal movement speed, it would take you forever. You would be doing like this, it would take you forever. While if you put some kind of scaling in, it's a lot more comfortable to use. And I will be explaining all this in this video. Now if people are interested in what I've been up to for this game as well lately, besides perfecting the Demeo stuff, I've also added some more first person stuff, like this. Well, yeah, I still need to work a bit on that, but I can move the character using the index controller right now, the knuckles. You can move him. And this will be for maybe another tutorial. I can also just change the camera angle, but as you can see, it's not quite there yet. It still needs a bit adjustment. And this is all using my my index controllers. If you just switch to Demeo mode again, we're back here. And even there we can control our character, which is very nice. Alright, well, let's dive into it. Yeah, let's quit the game. And I'll just show you the code. There will be no interactive coding today. I'll just show you what I have and explain how it works and some common pitfalls. Alright, here we are. So let's take a look at the handle Demeo camera function, which is where all the Demeo-like camera stuff happens. So the first thing we do is one big if check. It goes all the way up here, so the whole function. The function will only get executed if our current camera mode is via camera mode Demeo-like. This is a custom structure I made, custom enum, which is just a way of saying what camera mode are we in. I've got Demeo-like, first person, cutscene and UI. I probably only really need Demeo-like and first person. Feel free to make your own camera mode enum for stuff like this. For most games it will just always be first person or UI or something, but I want to switch between Demeo camera and first person camera for this specific game. Alright, so we check if you are in the right camera mode, and we also check if our right and our left hand objects already exist. So you probably know this, but if you put an if and then just an object there, it will check if the object is not null. If it's null, it's nothing, it does not exist. If it's not null, it will resolve as true in an if statement. Alright, so the first thing that we do in our handle Demeo camera, which gets called every frame by the way, maybe tell you why I call it, where I call it every frame. So if I go to my patches, I've got some here, I've got a handle camera function, which is just tied to the game's tick function. If your Unity game does not have a tick function or anything equivalent, you can try finding a late update somewhere, or just anything that ticks every frame, or every server tick or something, because that's what my code relies on, that it gets executed every tick. And this function is very simple. So if we are in first person, we handle the first person camera. If you are not in first person, we handle the Demeo camera, or we handle the camera like it would be Demeo. Alright, so now that we know why it gets called every frame, let's see what happens. First thing we do is add physics to the VR origin. Now the VR origin is something you will probably have to make for every Unity VR mod, because you can't directly move the camera yourself. If your camera is in VR mode, you can only move it by parenting it to an object, which I call the VR origin, and then moving that VR origin instead. So I defined a VR origin just in my class. It's just a new empty game object at first. Then when switch POV is called, so the first time we want to actually do something with the camera, I just do some stuff like adding a skybox, get the original camera, check some things. And if you do the switch to first person, I set the VR origins parent to null, because the VR origin switches from first person to Demeo mode, so don't worry about that. I set its position to the player character's position. And if there is no original camera parent yet, I set the original camera parent to the camera transform.parent. I do this because after that I will set the camera's parent to the VR origin. And if you don't set this original camera parent first, then you do not know to what your camera was originally parented, so you cannot go easily back to the state before you parented it to your VR origin. And then I also attach my right and left hand to the VR origin if they exist. This is if I switch back to Demeo mode. I set its position, rotation and scale to the original camera parent stuff, and I set its parent to the original camera parent. So that way the camera is parented to its original parent again. Anyway, that's enough confusing VR origin stuff. The important thing to take away is that you want to have a VR origin as a parent for your camera. And normally this VR origin will not have a rigid body component by default. So we quickly check for it. Remember, this gets called every frame, so we only want to do this once. If it does not have a rigid body component, we just add one. And very important is that we set its use gravity to false. Otherwise, our camera will basically fall to the ground. Now, this rigid body is important because without it we can't set a velocity for the VR origin. So this rigid body is purely here so we can set a velocity. Alright, so if it does not exist, make it and then get it as a component of VR origin. Alright, now comes the logic. By the way, this code is all available on my GitHub repo. I will link it in the description and you can get the latest version from there in the handle Demeo camera function in Camera Manager. Anyway, so if we are grabbing with both our hands, that means we either want to scale or rotate or both. So we've got something separate for that. Else, if we are not grabbing with both our hands, then we check if you are grabbing with any hands, which will just be moving the camera. But let's, you know what, let's do moving the camera first. We reset some scaling and rotating flags here, don't worry about that yet. Now for moving the camera, we want our speed scaling factor. This is a thing that makes you move faster the further away you are from the player. So let's see what we do here. We get a vector 3 distance between the main character and our VR origin position. So we just get the distance between these two, then we get the absolute value of it, just to make sure we don't get a negative speed scaling factor. And then we just clamp this between 1 as the lowest value and the far clip plane distance as the highest value. So we just set limits on how low and high the speed scaling can be. Alright, now if we are grabbing with our right hand, which is something I set up in input, you can make this ball yourself or look at my code later, how I set this up. We eventually set the velocity of the VR origin physics object, but we need to mess a bit with the speed for it. So our first intermediate step is the scaled speed, which is our right hand pose dot velocity, which you should be able to set up using my SteamVR input tutorial, times the speed scaling factor. Alright, now we will also need to adjust the speeds. We need to make the speed in the opposite direction, because otherwise if you try to move your hand forward while grabbed, you will move forward, which does not feel like grabbing, it feels like pushing. which is not really what we want. It does not feel as nice to use. And then the most important part is when we set the velocity, we also want to rotate our adjusted speeds via our VR origin rotation. Because if you don't do this, it will not take into account where you are looking. So it will not always pull you forward when you pull forward. It will instead pull you in the global x direction every time or something. And for the left hand grab we do the same. So to recap, we just get our pose velocity, we multiply it with a speed scaling factor, we get the negative of this resulting speed, and then we rotate it with our VR origin transform rotation. Keep in mind, this rotation needs to be in this order. So you can't switch the factors around here. Alright, so that is our moving the camera stuff. Now let's go over to scaling. So if both hands are grabbing, we do some initial setup. So if initial hand distance equals 0, which is something I define here, initial hand distance equals 0f. So this will always get executed the first time we try to scale something. Then we set our initial hand distance to just the distance between our right hand and our left hand position, which is the initial hand distance. We will also set the zoom origin to our VR origin. Alright. After this we can calculate the current hand distance, which again is the distance between the right hand and the left hand. And our scale will then be the current hand distance divided by the initial hand distance. So the hand distance will get updated every frame, and our initial hand distance will only get set if we pass this check, which will be when we first start scaling, and when we release of the hands we will also reset the initial hand distance. Again, this is important so you can do things incrementally, so you don't have to do your scaling every time in one big swoop. Now is the time for the actual distance scaling. Keep in mind this is a distance scaling and not world scaling. It will just move the camera closer to stuff, which also feels like scaling. And here we just set a VR origin position to a linear interpolation unclamped. If you don't know what linear interpolation is, I suggest you look it up. It's not that hard. It's just interpolating, finding a point on a line between point A and B, where point A is our main character position, and point B is the zoom origin, and alpha is our scale variable. So depending on our scale variable, we will be somewhere between the main character position and the original place where we started zooming. Now this is an unclamped lerp, which means that if our scale is bigger than 1, it will extrapolate from the line between the player and the zoom origin. So it will go actually further than the zoom origin, it will zoom further out than our initial origin. So it's important that you have an unclamped lerp here. And that's our scaling. Now for the rotating. We also have some setup. So if initial rotation is true, again this is something I set up here in the global class variables. Initial rotation equals true. You also get the previous rotation vector, initial rotation point. Alright. So if this is an initial moment of rotation, we will find the points where we'll rotate from, which will just be the middle of our left and right hand. So lerping between the two hands and selecting 0.5 will give us exactly the point in the middle. We will set our previous rotation vector to the left hand position minus the rotation point. So yeah, for this you will need to do some vector math in your head. It's just a vector that points from the middle of our hands to the left hand. And we'll also set its y component to 0, which basically means that we flatten it. We will not give it a vertical component, which is important because usually you do not want to rotate the world upside down or anything, you just want to rotate it in a certain way. And after this we set our initial rotation to false, so this does not get executed anymore. Now our current rotation vector will be the left hand transform position minus the right hand position. Yeah, and we also set its y component to 0, so again that it is flat. And then we are finally able to calculate an angle by which to rotate with. So we define an angle here, and we calculate it by vector3 dot signed angle. It's very important that you have a signed angle here, otherwise you will only be able to rotate to the left or right, not to both left and right. And this function just accepts two vectors, a from vector, a to vector, and an axis. So we will rotate from our previous rotation vector to our current rotation vector around the global up vector. And then we just divide this angle by 2 so that we don't rotate too quick. Because remember, this function gets called every tick, every frame. So every frame we determine a very small angle between these two vectors. And if you don't curve it down a little, it will rotate you very quickly, because it will rotate you every frame by a very small amount. And then it's time to do the actual rotating. So for this, again, we go to our VR origin, transform, we rotate around the initial rotation point, which again is the middle of our hands. You can set this to another point if you want, but I believe it works great if you set it to the middle of your hands. So rotate around that point, around the up axis, with the angle we just calculated. And don't forget to set your previous rotation vector to your current rotation vector after this. And the rest of the function is just cleaning up some stuff. Like if we find that we are not grabbing at all, which is this else over here, we reset our flags, so initial hand distance equals 0 again, initial rotation will be true again, and we stop our extra camera movement. This will not stop your camera movement completely, it will just stop the component we add to it by moving the camera manually. And we also have to reset the scaling and rotating flags over here if it detects if we stopped rotating and scaling. So basically that's the function. You saw how it works. If it looks a bit complicated, you can always look at the code on the GitHub repo, and feel free to ask me any questions on the Flat Screen 2VR modding Discord. So thank you for watching, and until next time.